lot of pressure. All right. So if you have not turned your homework in, your goal should be to do so by the end of the day. All right, I know we don't have extensions, but sometimes you can find some time. If you want to go down here at lunch, you'll have to talk to another teacher because I don't even have game lunch today. I am doing advisory lunch, so a reminder, my advisory people, advisory lunch today. Because we are still finishing up our Discovery Day sharing. So on your paper for 623, you have this. And what we're going to do is in the empty boxes, we're going to either fill in what the expressions became or what they did to get there. So we'll do a couple together, and then I'll let you guys try to roll and finish on your own. Matt, go ahead. Just don't push so hard. Now, I'm probably also going to do this on my paper while you guys do it on yours, so at least I have a copy to give to our friends who are absent today. So they tell us in like the result of this that from the original equation to get down to these boxes, what they did was use the distributive property. So if they used the distributive property, what do you think I should draw? What do we always draw if we're distributing? Emery?
Arrows.
The arrows, and what needs to distribute? Well, nothing in Mat B, but in Mat A, this 2 needs to distribute. So whether you draw it above or below, we should draw those arrows. Now, after having drawn the arrows, those are telling us to do the multiplication. So on your paper, do the multiplication and bring down whatever you have now. In Mat B, nothing's going to change yet, so just bring down everything. I can't let you be this close to going to sleep on a Friday. We should probably use some random cards to make sure we're all awake.
I'm awake.
Are you alive, alert, awake, enthusiastic?
Me too. I am. I was in 20 minutes ago. I wasn't 30.
Sophia, what is the next thing? You don't even have to really like focus too much on what they have, but what's the next thing that you would probably do with this? So by the way, let's go ahead and say these are like, I don't know, let's just say they're equal just so we can put a symbol between them. So let's hypothesize if we have left side equal to right side. What would you do now? And if you want to look at the next box to kind of guess, well, how'd they get there? What's funny is when you said like, you weren't using it for this purpose, but you could have just said add like terms. So we are going to add like terms. And guys, what we're making here, Jack, do this, but point at the wall. So, yeah, that poster. That's essentially what we're making on our paper. So I had it up here yesterday, but we'll see if it hangs for the whole weekend, because I had to put a bunch more tape on it, because the cinder block walls like to throw posters off. But if you are solving an equation and you need help, go look at that poster. Or come look at your math notes that we're writing down right now. So we added like terms, and if you want to double check that, use some symbols or some colors. I could even just color code just some of them. So what's 2x plus 4x? 6x minus 3x? Oh, hey. What's 4x plus x over here? Oh, hey. Any questions on how we got down here to step 2? Now they tell us what to do. You do it. And if you're like me and you like to show your work, I'm going to actually like show what they tell us to do. What do they tell us to do next? Subtract 3x from both sides. What do we now have, Ezekiel? Yeah, good catch. -4, 2x plus 8. Not here. Eli, what are you thinking we're going to do next to get from this step down to here? Subtract 8 from both sides. So I'm going to grab my red because I always kind of do my changes. So we did subtract 8 from both sides. And guys, if you want to start like a shorthand, we could say like OBS for on both sides. On both sides. And then, Arfon, what would you do to finish this out? Oh. Yeah. They tell us divide both sides on both sides. And we would get x, and if we made this equal, x is equal to what?
-6.
-6. Questions on what we just did or what should be written on your paper now? Guys, that is yours to use. Not just write down once and never look at it again. When you're solving equations on your homework, look back at this. So because it's in front of your face right now, look at 73. See if you can fill in the in-between what they did. And if you want to write off to the side, like in words, what they did, you can. What we mainly want to show is like the in-between steps of how did they go from the beginning to step 1, from step 1 to step 2. So work with your partner. Let's fill those in or write off to the side what they actually did. Maybe this one I'll actually do on the smartboard. I might copy a new picture out. All right, I'll give you guys a minute to think and work. If you get done with 73, try either of these. And this will be on your graph paper. But if you get done with 73, try either of those. We're going to practice those together. I bet we don't need too long for this 73 one because a lot of it's already written down for us. Jane, from their beginning equation, because we always write down the beginning equation, down to really like step 1 or step 2, I don't know what to call it really, but what did they do? They combined their like terms because that's how we start cleaning up pretty much always. So x was 6x, -1 with +5. You guys, this is where you got to be careful. That's -1. It's not -1 because you can't minus it from the 3x. This is why I've been trying to brainwash you since August. Minus is really just the shortcut for saying that's a negative. So that's how we get 4. That's how we get 7x. Sweet. Carolina, what do we do now? Add 4 on both sides. On both sides. Bethany, what do we do now?
Subtract 3x.
Yeah, you can say minus. I'm just saying, like, we made up, like literally mathematicians made up subtraction to add negative. And in some situations it does make sense to talk about it as takeaway, right? Because if you have 7x, you can take away 3x. There are certain situations where we can't do it, but mathematically we do. Kamal, what do I do now? I got 4x equals 8. Subtract 4 would end up, so let's play this out for a second. Guys, look up here. This is the trap door. I knew what you meant. But if Kamal subtracted 4, this is what this would turn into you now have 4x minus 4 equals 8 minus 4, which is really 4, but like, you got to be careful with what am I trying to do? Come on, why'd you switch it to division? What is 4x? What's happening? Is it addition, subtraction, multiplication, division? So this is multiplication, right? And Kamal's thinking, okay, so to undo multiplication, we divide. We always got to be thinking about the inverse operation. What undoes things? So when we divide by 4, that does undo those things. And we get x equals 2. Questions? Jack, pick A or B. B. We're doing B. On our graph paper, we're going to start left side, right? So left side has 3 times 4 plus x. Right side has x plus 6. We're going to call these equal because they tell us that. If you want to draw a little fence down the middle, you can keep your left side, right side honest from each other. Work to solve this. There are multiple ways we could do it. I don't care which way you do it. I have a suggestion that distribution first would be best, but that's up to you. You could divide first, but it'd get a little messy. I don't think division by first would be a good idea, but that's up to you. The more we practice this, the more comfortable we will get. Devin, what are you going to do first here? Yeah, because if we divide by 3, x divided by 3 would be not great. 6 divided by 3 would be fine. Because, guys, we practice problems together in class that you probably have written down that you would think, okay, divide by 3 to undo that. But over here, the divide by 3, when it happens to be x, would be not so nice. The 6, okay, sure, whatever, it'd become 2. But I agree with Devin. Let's just do distributive property. So, bada boom, bada boom. What do I get from that distributive property? 12 plus 3x. Be careful not to forget that second one. And we bring down whatever does not change. Donna, what do you want me to do next? We could. Now, this is where I have, like, I'm trying to think of a word different than advice. So, guys, to make your life the easiest, deal with your x's before you deal with your constants. So Donna's absolutely right. We could subtract 6 from both sides. We probably still will. But we would like to get rid of whatever x, the like lowest. So not the like smallest, because sometimes it'll feel bigger when they're negative. If you have negative x values, you want to get rid of the lowest x value you have. So up here, what's the lowest x value that we have? So anybody? X. Just the single x, right? Single x versus 3x. And the reason we do this is when we take away just 1x, what do I get over here?
2x plus 12.
2x, right? Positive 2x. Stick with me here for a moment. What if I did minus 3x? Now I end up with negative x's over here, and that's more difficult to deal with. So you can do it whatever way you want. You don't have to follow my advice. But I'm telling you, from my many years of algebra experience, if you get rid of your lowest x first, you'll make the problem easier. Now be careful, trapdoor. Some people will be like, oh, x minus x, this is just 3. No. 3x minus x is 2x. And then this x minus x, that's gone. Now, I can't always make us avoid any negatives, as I'm sure some of you are realizing the next step. Lane, not here. Sam, what would you do next? Now that x's are over on the left side.
I would probably subtract 6 on both sides.
So if we subtract 6 on both sides, because we totally can, I would not write this down yet. You get 6 plus 2x equals 0. And that feels kind of silly. So guys, at this point, put your pencil down for a second. We have our fence going down the middle. This is really saying, like, this side, that side, this is your property, this is your neighbor's property, whatever you want to call it. And we're going to make one side belong to the variable. We're going to make the other side belong to the constants. Do I still have variables on both sides here? No. So since I don't have variables on both sides, what has essentially happened is my left side has become my variable side. Like, the variable is on that side. There's no reason to move it anywhere else. So that means that this side should become our constant side. So what should I do to get all of the constants over there, Sophie? If I subtract 12, now all of my constants are together. Now, there was nothing wrong with what Sam told me to do. It would have just taken us a couple extra steps to get to the answer. Fine. Does not matter. Math is not about being fast. But if you want to make things a bit easier, that's my advice. Once your variables all land together, that's the variable side. Leave the variables over there. So now we get 2x equal to, yeah, we still have to deal with some negatives. Careful, negative 6 minus 12. Negative 6 now. And Raiden, if I have 2x equal to negative 6, what do I do now? Yeah, because this is multiplication. Raiden is saying, can't we divide by 2? Yes, we can. And Bob the Builder can fix it. When you hear yes, we can, do you not think of Bob the Builder?
Oh, no, I do. And I didn't even watch that show.
Wow.
Bob the Builder.
Yeah.
Questions. Why are you so unamused when I you look angry that I was singing Bob the Builder? You make me self-conscious.
No, it's okay. Hey, don't make Mr. Hudson self-conscious.
zoned out.
You're zoned out while your math teacher's singing Bob the Builder?
How dare you?
Alright, so,
That's
hold up. If we look at A real quick, we're not going to actually write this down and do it. But look at A for a moment. And tell me if you see anything kind of weird. No, that's just a complaint.
On one side, there's a lot
Sophie.
of creative.
I like that you put your hand in the air. Wave like you just don't care.
I feel like they could be for
There could.
It's not very organized.
Okay. So what's the first thing we did last time? Remember?
Adding like terms.
We added,
add a lot of like terms on the left side.
Eli, you notice anything sus?
The left side is equal to 0.
Negative 2 and 2x. Positive 5, negative 5. Wait. Negative 2, positive 2. Guys, after you would combine like terms here, you would end up with
0 equals 6x.
what is x?
0.
Don't fall in that trap of thinking, I don't know what to do because we have nothing. Nothing is a number. This is multiplication. The rules don't change. How do I undo multiplication?
Divide.
What's 0 divided by 6?
0.
I'm doing this right now. I have 0 pizzas that I'm dividing the 6 of you. The rest of you are mad that you didn't get any pizza, but so are the 6 of you that I divided zeros. Guys, you can divide if 0's on top. You cannot divide if 0's on bottom. So here, x would just be equal to 0. That does not look like a what?
X.
Oh, I shouldn't have showed this yet. Matt, A or B? Hurry up. All right, A. We're doing A. We're doing A. This is it. This is the last one. We're doing A. Ooh, I'm going to write plus -1. I don't know about you guys, but I just don't like subtraction, so I'm just going to write negatives for any of those subtractions. Matt, coming back to you. First thing we do? Yeah, like terms. We're looking for like terms. And if you look at the poster over there, simplify each side if necessary. Use the distributive property. Combine like terms. It's on the poster. I'm telling you, use the poster.
The poster says it must be true.
So 5x and -x, what do we get? 4x plus -1 equal to... Oh, there's no like terms to combine over here, so I just drop it down. Get low, get low. All right, so now, you already talked a few times, so have you. So, are we just, okay, I need to shuffle them. Better, I left some of these over here. I bet if you aren't waiting for me, you can almost be like done with this by the time I get done shuffling.
Well, I'm already done.
Sam, your card jumped out of the
Yeah.
deck. Sam, what would I do now?
Subtract 2x on both sides. I
Subtract.
mean, add 2x on both sides.
Hey guys, Sam did a great job pointing out the trap door you might fall in. This is a negative 2x, so we need to add 2x. And the reason Sam chose this one to get rid of, it's the lowest, right? He's looking at the x's first. He's dealing with the lowest one first. And now the variables have claimed the left-hand side. 6x plus -1 equal to 11. Emery, what do I do now?
Wait, let me see what I did next. Next I added a +1, so that it became like 6x.
Success. That's what we're shooting for. We're shooting for success.
Then it became 6x equals 12, and then I divided by 6, and then I got x equals 2.
The rest of this time is yours to work on homework.
Thank you.
I mean, it's not like Jesus said it was homework time. I'm in charge of it.
Well,
None of you guys are that quiet at saying anything.
I'm here
Like, I
to
get
talk
it. We're old, but we can still hear you.
The guy that was good stuff from Mr. Combs is
Okay, let's be gentle.
No, you have no idea.
He has more experience than most people. Let's leave it at that.
Yeah, Lane was like,